So I want to do a video on completing the square, and I want to talk about some shortcuts that you can use. The first thing before we start this video, and really just kind of some introductory information here, is that we have a thing in algebra called a perfect square trinomial. And this is what they look like: a plus b squared and a minus b squared. And these are the factors of an expanded format of this. And for a plus b squared, it's going to be a squared plus 2ab plus b squared. And for a minus b, it's going to be a squared minus 2ab plus b squared. Now, the goal when you are asked to complete the square is if you have a trinomial that looks like this, or you have a trinomial that looks like this, the goal is to make it look like this, to make it this x plus a number, x minus a number quantity squared. And I'll explain the reason why in a minute, but that's the most important part, is you have to understand what you're trying to do. Now, let's take this very first problem here. We have x squared plus 6x equals 7. And so what I'm going to do is I'm going to rewrite this: x squared plus 6x. I'm going to leave a big space, and then I'm going to say equals 7. Now, what I'm looking for is I'm looking for, this is a squared. Okay, this term here, this is a squared. This is 2ab. I need to find what number makes this b squared so that I can turn this into that. Okay? Now, the simplest and easiest way to do this is to take your middle term, just the number, the coefficient, okay? And you're always going to do two things to it. You're going to divide it by 2, and then you're going to square it. Okay, you're going to divide it by 2, and then you're going to square it. So, if I divide 6 by 2, I get 3, and 3 squared makes 9. Okay? And if I add 9 to the left-hand side, I have to add 9 to the right-hand side. That's the big deal here. If you do something to the left, you have to do it to the right. Now, if I do that, I end up with x squared plus 6x plus 9. And, of course, 7 plus 9 makes 16. Now, I want to turn this into this factored form, this nice, neat, factored form here. Okay? If a squared is x squared, then a has to be x. Okay? If b squared is 9, then b has to be 3, right? Because the square root of 9 is 3. So x plus 3 squared equals 16. Okay? And why would we do that? Why are we doing that? Well, the answer is very simple. I want to solve for x. And if I can get x into this format, this x plus 3 squared, I can take the square root of both sides. So I want you to take the square root of both sides. Now, the square root of the left is just going to be x plus 3. The square root of the right is going to be plus or minus 4. And it's plus or minus because of the properties of square roots. And you need to know that. And I'm not going to go into that in this video. Hopefully, if you're watching this video, you already understand why it's plus or minus 4. But the square root of 16 is plus or minus 4. Now, move this 3 to the other side of the equation, and what do you get? You get x equals negative 3 plus or minus 4. And I always like to break my answers up like this. Negative 3 minus 4 is negative 7. Negative 3 plus 4 is 1. And so those are your two answers, negative 7 and 1. Okay? Now, the purpose for this is I want to solve this quadratic equation that I've been given, x squared plus 6x equals 7. And completing the square is one of the methods to do that. And it's a very, very handy method to know. It comes in very useful in a lot of pre-calculus applications like conic sections. And it can also be very, very handy in Calculus 3 when you're doing rotations and things like that. So if you need a little refresher on completing the square, this is the way you do it. Okay, so let's take this same concept, problem number 2 here. And we've got x squared equals 8x minus 9. So I'm going to move this 8x over. So get x squared minus 8x equals negative 9. Now notice I always leave the constant term on the right. Okay. Now I ask myself, what number needs to go here? And then of course that same number has to go here. So what I like to do is, again, take this number here, divide by 2. Well, negative 8 divided by 2 is negative 4. Negative 4 squared is plus 16. And if I add 16 on the left, I have to add 16 on the right. So if I do that, what do I end up with? I end up with x squared minus 8x plus 16 equals 7. Okay? And then what? Well, now I can rewrite this. This is a squared. This is b squared. The middle term is negative. So I want to rewrite this as this, a minus b squared. So a would be x and b would be 4, right? Because this is a squared. Take the square root, you get that. This is b squared. Take the square root and you get that. And it's negative because the middle term is negative. Okay, squared equals 7. Okay, now take the square root of both sides. You get x minus 4 equals plus or minus 7. And of course, if you bring this 4 over, you get x equals 4 plus or minus 7. And of course, 4 plus or minus 7 is going to give us 2 answers. Or plus or minus, excuse me, the square root of 7. Got to remember my square root signs there. So we get 4 plus or minus the square root of 7. Now, if you want an exact answer, that's going to be your answer. 4 plus or minus the square root of 7. If you want an approximate answer, you're going to type this into your calculator. So 4 plus the square root of 7. And I get 6.646. I'll get it right in a second, y'all. And if I type 4 minus the square root of 7, I get 1.354. Okay? So that is my exact answer, and those are my approximate answers. Okay? So exact and approximate. Okay? Last one, final one here. We've got 3x squared plus 5x minus 2 equals 0. And one of the difficult things about completing the square is you usually end up with fractions. The reason for that is that for this method to work, the lead term, the highest order term here, has to have a coefficient of 1. So the way to do this is to divide everything in the equation by 3. Now, I end up with x squared plus 5/3 x. And I'm going to move this term to the right-hand side and leave a space here. So that equals 2/3. Okay? Because it was negative, and we're going to move that over, and it's going to equal 2/3. Okay? Now, my goal is I want to come up with a number here that makes this a perfect square trinomial, and I have to put that same number here. Okay, so what number will that be? Well, let's take a look. Remember what I told you, half of 5/3 and then square it. Well, I like to come over to the side. This is kind of scratch work. What is 1/2 of 5/3? Well, it's 5/6, right? Because you just multiply. 1 times 5 is 5 and 2 times 3 is 6. Half of 5/3 is 5/6. Then what? Square it. Well, what is 5/6 squared? It's 25 over 36. It's 25 over 36. So, what goes here? 25 over 36. And what goes here? 25 over 36. Now, what do we do? Well, now we have to complete the square. So if this is 25, this is b squared. So b would be the square root of that, which is 5/6. And this would be a squared. So a would just be x equals. Now, what is 2/3 plus 25 over 36? Well, it comes up to be 49 over 36, which is a nice number because you can take the square root of it. Okay, so now we take the square root of both sides. The square root of the left-hand side is x plus 5/6. The square root of the right-hand side is plus or minus 7 over 6. So then what? Subtract 5/6 from both sides. You get x equals negative 5/6 plus or minus 7/6. Or you could write it this way, which is negative 5 plus or minus 7 over 6. Okay? And if you do that, obviously one of your answers is going to be negative 5 minus 7. Well, negative 5 minus 7 is going to give you negative 12. Negative 12 divided by 6 is negative 2. And negative 5 plus 7 will give you 2. And 2 divided by 6 is 1/3. And so those would be your two solutions, negative 2 and 1/3. So this is a fun little way to complete the square. And it's a very, very handy procedure to keep in mind. And if you've ever used the quadratic formula, you see how this looks very similar to the quadratic formula. And I have a different video on using the quadratic formula, but sometimes you do need to know how to complete the square. The quadratic formula is not going to help you with what you're trying to do. So if you have any questions about this, please let me know.